Two prototype trains race toward each other from opposite directions on a Chinese test track, and in the instant they pass, their combined closing speed touches nearly 900 kilometers an hour, faster than most commercial airliners cruise at altitude. That is real. It happened during official trials, it's been independently reported, and the train that achieved it is now on track to become the fastest conventional passenger train running scheduled service anywhere on Earth. Every figure in this video comes from verified railway industry reporting and official test data, because a claim this specific deserves a genuinely careful explanation rather than just a dramatic headline. By the end of this video, you'll understand exactly what this train has actually achieved, what that 900 kilometers an hour number really means, and where the real limits of this record still stand. Here's where the story actually has to start, because you can't understand why China built this specific train without first understanding the network it was built to run on. China's high-speed rail system had already grown to more than 50,000 kilometers of track by late 2025, more than the rest of the entire world's high-speed rail combined, connecting virtually every major Chinese city through a system built almost entirely within the past 2 decades. Here's the ceiling that network had been running up against, though. China's existing flagship, Fuxing bullet trains, the backbone of that massive network, top out at a commercial operating speed of 350 kilometers per hour. A genuinely fast standard by global rail comparisons, but one China's own rail engineers had already begun treating as a limit worth pushing past rather than a permanent ceiling. Here's the origin of the project, built specifically to break through that ceiling. In 2021, China State Railway Group began developing the CR450, a new generation of high-speed trains specifically engineered to raise that commercial operating standard by a genuinely meaningful margin. Not through some radical new form of transportation, but through a comprehensive redesign of the exact same wheel-on-rail technology the country had already spent 2 decades perfecting. Here's the actual engineering behind this new train, because the improvements go considerably deeper than simply making the existing design faster. The CR450 was built from lighter, more advanced composite materials, combining carbon fiber and aluminum construction, specifically to reduce the train's overall weight, paired with a water-cooled permanent magnet traction system and a redesigned body specifically, engineered to reduce aerodynamic drag compared to earlier generations of Chinese high-speed trains. Here's why reducing drag matters so directly to a train's real-world performance rather than remaining a purely academic engineering detail. At the extreme speeds this train is designed to reach, air resistance becomes the single dominant force working against the train's propulsion system, meaning even modest reductions in aerodynamic drag translate directly into genuinely significant gains in both top speed and overall energy efficiency across an entire journey. Here's the detail that shows this program wasn't chasing a single speed. Number in isolation. The CR450 family actually includes 2 distinct variants, the CR450AF, built with a sleek, arrowhead-shaped nose specifically optimized to minimize air resistance, and the CR450BF, featuring a more rounded nose design specifically engineered for stability at these ultra-high velocities, giving engineers 2 parallel aerodynamic approaches to compare directly against each other during testing rather than betting the entire program on a single design philosophy. Here's what the completed train is actually meant to deliver for an ordinary passenger, beyond raw speed alone. The finished design includes 4 distinct seating categories, including long-haul business class style seating and expanded luggage storage, alongside dedicated sound insulation specifically engineered to keep the cabin quiet and comfortable, even as the train operates at speeds considerably higher than anything currently running on China's existing network. Here's the number that anchors this entire story, and it's worth being precise about exactly what it measures, because getting this right matters more than repeating an exciting headline. The CR450 is designed for a commercial operating speed of 400 kilometers per hour, roughly 249 miles per hour, a full 50 kilometers per hour faster than the 350 kilometer per hour ceiling of China's current fastest in-service Fuxing trains. Here's what that specific number actually means for real passengers once this train enters service. China State Railway Group has confirmed the CR450 is expected to cut travel time on the flagship Beijing to Shanghai corridor from roughly 4.5 hours down to just over 3 hours, a genuinely significant reduction on one of the busiest, most economically important rail routes in the entire country. Here's the second number from this story, and it's the one that requires the most careful explanation. During official trials, an individual CR450 prototype reached a maximum test speed of 453 kilometers per hour, officially confirmed by China's own state-run Science and Technology Daily, as the highest speed ever recorded by a conventional wheel-on-rail train actually entering commercial passenger service. An important distinction, because France's TGV still holds the outright all-time speed record for any conventional wheeled train at 574.8 kilometers per hour, a mark set during a dedicated 2007 test run that was never intended to represent a train entering everyday passenger service. Think about the difference between those two records. For a second, the TGV's number represents the fastest a wheeled train has ever gone under any circumstances, while the CR450's number represents the fastest a wheeled train has ever gone while actually being engineered and validated for real, everyday commercial passenger operation, a genuinely different and arguably more practically significant category of achievement. Here's the number that produced this video's most dramatic headline detail, and it deserves the most careful explanation of all because it's also the easiest number in this entire story to misunderstand. During trials on a section of the Chengdu to Shanghai high-speed line, two CR450 prototype trains passed each other traveling in opposite directions at a combined relative speed of 896 kilometers per hour, officially confirmed by the China Academy of Railway Sciences as a new world record. Here's exactly what that number is actually measuring, though, because it's genuinely important to understand correctly. This isn't the speed either individual train was traveling on its own. It's the combined closing speed of two separate trains approaching each other from opposite directions at the same time, meaning if you added each train's own individual speed together as they passed, or if that combined total reached this record-setting figure. Here's why that specific passing speed record is still a genuinely significant engineering achievement in its own right, rather than simply a misleading marketing number. When two trains pass each other at extremely high combined speeds inside the narrow confines of a rail corridor, the resulting pressure wave and aerodynamic shock can create serious structural and stability challenges for both trains simultaneously, meaning safely managing a passing event. At this combined velocity required genuinely advanced engineering around structural bracing, window and door sealing, and aerodynamic pressure, management that has nothing to do with either train's individual top speed on its own. Think about why the distinction between these two numbers actually matters. For understanding this story honestly, a train hitting 453 kilometers per hour on its own is one genuine achievement, and two trains safely passing each other at a combined 896 kilometers per hour is a completely separate, equally genuine achievement. But conflating the two into a single, simplified China's train hit 900 kilometers per hour headline would meaningfully overstate what either number actually represents on its own. Here's proof this technology isn't confined purely to closed test tracks, but has already been validated on the exact routes real passengers currently use. CR450 prototypes have been tested since April of last year across a genuinely wide range of China's existing high-speed corridors, including the Shanghai to Chongqing to Chengdu line, the Chongqing to Xiamen line, and the Shenyang to Jiaozuo to Baotou line, with pre-service demonstration runs specifically appearing on the Shanghai to Chengdu route in late 2025. Think about what testing on real, currently operational passenger lines actually proves compared to testing purely on a dedicated closed research track, validating this train's performance on tracks that ordinary commuters already ride every single day demonstrates the technology can genuinely integrate with China's existing infrastructure and signaling systems, rather than requiring an entirely new, purpose-built network constructed from scratch before the train could ever carry a single real passenger. Before going any further into exactly how far this specific train still has to go before reaching real passengers, it's worth pulling back and understanding why China's rail engineers have kept pushing this particular technology forward for years, even as comparable programs in other countries have largely stayed flat. Here's the comparison that shows how differently China has approached this specific technology race. France's TGV, despite holding the outright test speed record since 2007, currently operates an everyday commercial service at a maximum speed of only 320 kilometers per hour, and Japan's Shinkansen network runs at a broadly comparable commercial speed as well, meaning both of the traditional benchmark high-speed rail systems most Western audiences would immediately think of have left their actual passenger-facing commercial speeds essentially unchanged for years, even while China has continued directly investing in raising its own commercial operating ceiling higher every several years. This is not a story of China simply catching up to an already static global benchmark. This is a story of China continuing to push its own already leading commercial speed standard even further forward, while the traditional comparison points most people still default to when thinking about the world's fastest trains have largely stopped advancing their own everyday passenger service speeds at all. And once you see that sustained, ongoing investment pattern clearly, the CR450 stops looking like a single isolated engineering headline and starts looking like exactly what it is, the latest incremental step in a multi-decade national program that has never really stopped pushing this specific technology forward. Here's the honest concession worth sitting with directly, because credibility matters far more than declaring this train already operational before it genuinely is. As of the most recent reporting, China State Railway Group has confirmed the CR450 platform is still completing its operational testing, and final design sign-off process during this year described specifically as the last major gate, standing between the current prototype stage and paying passengers actually climbing aboard, meaning as impressive as these test results genuinely are, this remains a train still finishing its validation process, rather than one already carrying real ticketed passengers today. Here's the specific number that shows exactly how much testing genuinely still remains. Independent reporting has noted that roughly 600,000 kilometers of additional testing still needs to be completed before passenger service can safely begin, a substantial remaining validation process even after the record-setting test results already achieved. Here's a second honest distinction worth including directly, because a fair account of the fastest passenger train has to acknowledge an entirely separate category of technology. Maglev trains, which use magnetic levitation rather than conventional steel wheels running on rails, remain genuinely faster in absolute terms, with China's own Shanghai maglev already operating commercially at 460 kilometers per hour, and a separate Chinese experimental maglev test vehicle recently reaching 404 miles per hour in just over 7 seconds of acceleration, meaning the CR450's fastest claim specifically applies to the conventional wheel-on-rail category of train technology, not to every category of high-speed ground transportation currently being tested anywhere in the world. So here's the full picture, start to finish. China's already massive high-speed rail network, the largest in the world by a wide margin, had settled into a 350 km per hour commercial ceiling with its existing Fuxing trains, prompting China State Railway Group to begin developing the CR450 in 2021, specifically to push that ceiling higher through lighter carbon fiber and aluminum construction, reduced aerodynamic drag, and a water-cooled permanent magnet traction system. That train is now designed for a 400 km per hour commercial operating speed, has already reached 453 kilometers per hour in individual testing, the fastest a conventional wheeled train has ever gone while being specifically engineered for real passenger service, and separately achieved a combined passing speed record of 896 kilometers per hour between two trains, crossing paths in opposite directions, a genuinely distinct engineering achievement in its own right. That technology has already been validated across several of China's existing real-world passenger corridors, promising to cut the flagship Beijing to Shanghai journey from roughly 4.5 hours down to just over 3, even as roughly 600,000 kilometers of additional testing still stand between this prototype and its eventual passenger launch. What you're actually watching in this story is the same shift that happened decades ago when commercial aviation kept pushing cruising speeds and efficiency higher, year after year, long after most casual observers assumed the technology had already matured and plateaued. A country that built the infrastructure first and then simply refused to stop improving what ran on top of it. China didn't just build one fast train. It built an entire multi-decade habit of making its fastest train a little faster every few years. And the CR450 is simply this decade's version of that same habit. If breakdowns like this, the real engineering and the real numbers behind China's biggest infrastructure achievements, are useful to you, hit like and subscribe, because there's more of this coming, including a closer look at what happens the first time the CR450 actually carries paying passengers on the Beijing to Shanghai line once its final testing is complete. So here's the honest question for the comments. Does a 50 km per hour jump in commercial speed genuinely excite you about the future of rail travel? Or does the remaining 600,000 kilometers of testing make you think this record is still more promise than reality for now? I read every single one.